Hello and welcome to my channel. In this video, we'll explore what Istio is, how it works, and how it can benefit your microservice architecture. First, we'll talk about Istio architecture and how it works under the hood. Then I'll show you multiple methods on how to install Istio on Kubernetes cluster, including Helm installation. I'll walk you through a few examples of how to manage traffic, request routing, and Canary deployment. And we'll talk about multiple ways to inject sidecars into the pod. One of the biggest topics of this tutorial is how to use Ingress gateway to expose applications running in Kubernetes to the internet. We'll install Cert Manager and use Let's Encrypt to automatically obtain TLS certificates and secure our APIs. Finally, I'll show you how to use Prometheus and Grafana to monitor latency, traffic, and availability not only of the services exposed to the internet, but also of internal applications. And of course, we'll use Kiali to visualize the service mesh inside our cluster. In the end, we'll talk about Gateway API and how to use it for both service mesh and instead of your typical Ingress. So what Istio is? Istio is open source service mesh that provides a unified platform to connect, manage, and secure microservices. It was created by Google, IBM, and Lyft in 2017 and has since gained significant traction in the cloud-native community. Istio is built on top of Envoy, a high-performance proxy that handles all the traffic between microservices. Istio works by deploying a sidecar container alongside each microservice instance in your environment. The sidecar container intercepts all traffic to and from the microservice, handling traffic routing, load balancing, service discovery, and other important networking tasks. Istio also provides advanced traffic management features like Canary deployment, A/B testing, and fault injection. Since Istio operator is deprecated, most people would prefer Helm installation. It's pretty easy to include in your deployment pipeline with other Terraform resources. You can use Istio.ctl to try it out, but realistically, you'd probably still use Helm to deploy it in production environments. This step is optional only to show you how to get default Helm values. Let's go ahead and add official Helm repo. Now, let's search for the base Helm chart that includes custom resource definitions, which are mandatory to install before you can deploy Istio.d. I highly recommend using the same version for the first try, otherwise Ingress gateway may not work for you. We can use Helm show values to get defaults for the Helm chart and pipe it to the file. Let's call it istio base defaults.yaml. You can open it and find values that you want to customize. It's pretty basic. For this video, I'm going to be using EKS cluster that you can create using my Terraform code. Now, I'll use Terraform as well to deploy the Istio Helm chart. You can put it in the same folder or follow along. First of all, we need to declare Helm provider. To authenticate with Kubernetes cluster such as EKS, we can dynamically obtain a temporary token and then use it to install Helm. Another way is just to point the provider to Kubernetes config on your local machine. Next, create a new file for the first Istio base Helm chart. You don't have to use Terraform. You can copy a command that exactly matches Terraform and execute it in the terminal. I prefer to use Terraform to make it easily reproducible. Let's call this release my Istio base. Point to the remote Helm repository, specify what Helm chart you want to use, then the Kubernetes namespace. If it doesn't exist, let's create it. Also, make sure to use the same version. Just in case you want to override any variables, you can use set statements. For example, set the default namespace for the Istio deployment. Recently, Istio team combined Pilot, Citadel, and Gallery into a single executable called Istio.d. Let's get the default values for it as well and use the same version. We would need to override a few variables for the Ingress gateway to work. Create another Terraform file to deploy Istio.d Helm chart. You can also find the Helm command to deploy it manually. Telemetry and namespace are default values, but we need to override the Ingress service and Ingress selector for the Cert Manager to work correctly and be able to solve HTTP 01 challenge from Let's Encrypt. In a terminal, you need to initialize Terraform first, then run apply to deploy both Helm charts. Let's check if the Istio custom resources were created. Also, we need to make sure that the Istio D pod is running. Alright, Istio is deployed to our cluster and we're ready to start managing traffic using the Istio control plane. Let's create a dedicated namespace for our first example and call it staging. If you want Istio to inject sidecars to all pods in this namespace, you add injection enabled label. In order for Istio to manage traffic, each service must have Istio sidecar. We'll have 2 deployments to simulate Canary. This deployment is version v1. Also, when we get to Kiali, you would want these labels to show up in the UI. It is a simple Golang app that uploaded to the Docker Hub. Since it's a public image, you can use it as well. The second deployment is identical except that it uses v2 version label. When we create this standard service in Kubernetes, since it uses single label app equal to first app, it randomly routes traffic to both versions v1 and v2. To manage and shift traffic, we actually need a couple of Istio custom resources. The destination rule defines what backend applications are used. They call it subsets. We have a subset for v1 version, which is also called v1, and another one for v2. You also need to add a target host. In this case, it's a service name first app. You can get all the values from the official Istio documentation. The second custom resource is virtual service. First, we also need to use the same target host. Same as in the previous example, it will target Kubernetes service first app. Then we can intelligently route traffic to different backends. For this example, we'll simulate a typical application upgrade when you need to roll out a new version of the app, in this case v2, and start shifting traffic to it. Sometimes it's called Canary deployment. When the traffic hits the new version, you can monitor status codes and decide if you want to proceed or abort. Alright, let's start routing traffic to only version v1. Now, to test, we need a client inside Kubernetes, which also have a sidecar. Port forward won't work in this case. Later we'll use a gateway. Let's go ahead and apply example 1 folder. Check the status of the pods in the staging namespace. If you add wide flag, you can get internal IP addresses of the pods. Take note of those two. We also have a single Kubernetes service in that namespace. If you check endpoints on that service, you'll get 2 pods. So if you access the service without a sidecar, you would randomly receive traffic from both versions v1 and v2. For the test, SSH to the client in the backend namespace. That pod is based on curl image and has infinite loop to prevent it from exiting. Let's use curl in the loop to hit our first app service in the staging namespace. Since we used Istio virtual service, traffic is only routed to v1 version. Later, I'll show you how to visualize this traffic in the UI. Now, let's say we want to upgrade our app to version v2. First, we want to route a small percentage of the traffic to that version and make sure it's healthy. Add wait attribute with 90% value. Also add another destination rule that will send traffic to v2 version, but only 10% of the traffic. Everything is ready. Let's apply the new destination rules. On the bottom window, you can see that v2 versions rarely appear, since we only route 10% of the traffic to that version. Without Istio to implement the same task, you would scale version v1 to 9 pods and create a single pod for v2. Well, you can have any number of pods, just need to keep the ratio. With Istio, it does not matter how many pods you have. You can still intelligently route traffic. Let's say we're now confident that v2 version has no bugs. Now we can start routing half of the traffic to the new version. And of course, you can automate this in your pipeline, but first you need to understand how it works. Let's apply it again. Now we receive equal amount of traffic on both versions. Also, you can implement similar routing with Gateway API, but with experimental custom resources only. We'll talk about techniques at the end of the video. At this point, we're confident in our version and we want to route all the traffic to it. Apply it again and you'll see immediately immediately that all the traffic is now routed to v2 version. In this section, I want to talk about multiple ways you can inject sidecars into your pods. The first one and most common is to use inject label. You can also set the value to disable, and other methods won't work either. The second method is to use pod inject enabled label. Now, the third one is to inject manually, but you should use it only when you're trying to test something. For example, this deployment doesn't have labels and Istio should not inject the sidecar. Let's apply and see result. Alright, the first deployment has a sidecar and the second one doesn't. To manually inject sidecar, you need to use Istio CLI and specify the path to that deployment. If you get the pods in a few seconds, you should see that the Istio sidecar was injected into the second pod. In the following section, I want to show you how to expose application running in Kubernetes to the internet using Istio Ingress gateway. We'll also use a Helm chart to deploy it to our cluster. Similar to the previous charts, let's save the default values locally, just in case if you want to override some of them. I'll keep all default values for the gateway. For example, you can use service annotations to specify what kind of load balancer you want. In AWS, you probably want to upgrade classic LB to a network load balancer. Create another Terraform file for gateway deployment. As you can see, I'm not going to override any values in this deployment. Keep a note that we'll deploy it to the Istio Ingress namespace. Let's run Terraform apply to install the Helm chart. Now we can check if the load balancer was created. If it's in pending state, try to describe it and find any errors. You can also get events in that namespace. For the third example, we'll use production namespace and also inject the sidecar to all pods in that namespace. Then identical deployments for version v1 and v2. The same service, just a different name. Same destination rule that defines two subsets for both versions. Now, the virtual service must have external DNS name under the hosts. In my case, I have app-devops-by-example.com and the second one for internal Kubernetes routing. In this case, we have additional attribute gateway that uses the name of the gateway that we're going to create next. Similar to the previous example, we'll route 90% of the traffic to v1 and 10% to v2. You can also use different prefixes if multiple services hide under your API, similar to a typical ingress. To expose application to the internet, we need to create a gateway object. This is Istio custom resource and not a gateway API from Kubernetes. Keep this in mind, they are very similar on purpose. On line 9, selector uses pods labels to identify what gateway to use. To route plain HTTP traffic, you select port 80 and HTTP protocol. As a host, you put your DNS name. You can use the same gateway to route multiple domains, just list them here. Let's check the pod labels on the Ingress gateway to make sure that it will match our label under the selector. Istio gateway looks like it should work. Let's go ahead and apply example 3 folder. Check the status of pods. I want to show you a trick that you can use to verify Ingress before you update DNS. Hostname is just a header. You can use curl and pretend that you already have a proper DNS. For the address, you specify the load balancer hostname. Alright, it works. We got response from the app deployed in Kubernetes. Now let's create a CNAME record for our domain. I use Google domains, but it doesn't matter. Just create a CNAME if it points to another hostname, or a record if you need to point to the IP address. In a few minutes, check if DNS is updated. Finally, we can use our custom domain name to reach the app. That was pretty simple. The next step is to secure our application with mTLS certificate. First, we need to deploy a cert manager, including all custom resources that come with it. In some environments, like GCP, you would also need to create additional firewall rule. In AWS, it should work out of the box. Let's apply it. To automatically obtain TLS certificate from Let's Encrypt, we need to create a cluster issuer. You can also create just issuer, which is namespace specific. When you're just getting started with Cert Manager, you should use a staging environment. It's almost identical to production, just different URLs and fake certificates. Also, you must specify what Ingress class will be used to solve HTTP 01 challenge. That's why we had to override applied some defaults when we deployed Istio D. When you test and able to obtain a certificate, you can switch to the production issuer. They have a strict quota for a number of certificates. Let's apply both staging and production cluster issuers. Check if both of them are ready before creating certificates. To automatically get certificates on a typical Ingress, you would use annotation. At this time, it's not supported on Istio Ingress, but it works on Gateway API. As a workaround, we can create certificate resources separately. Use your domain name. To test certificates, update the name to staging issuer. Also, it must be created in the Istio Ingress namespace where you have your gateway pods. When you create these certificates, Cert Manager will obtain a certificate from Let's Encrypt and store it in Kubernetes secret. The certificate is valid only for 90 days and Cert Manager will automatically renew it and update the secret. Let's apply it. If you get certificate immediately, you can see it's not ready. In case it's stuck in not ready state, you can describe that certificate and find that certificate request was created. Then you can describe the certificate request. You can see that order was created. Let's describe it as well. Then the challenge was created. Describe the challenge. In my case, certificate was issued and the challenge was deleted already. If you get certificate, it should be in ready state by now. Check that the Kubernetes secret was also created. Now, to secure the API, you can add another rule for port 443 and use HTTPS protocol. You also must specify secret name that was created by the certificate resource and a host. Let's apply it again to update the gateway. To check the certificate, you can use OpenSSL tool. This is your certificate. You can try to access your API from the browser. It looks like it works. Certificate is valid and issued from Let's Encrypt. In the following section, we'll use Prometheus and Grafana to monitor Istio and applications. I'm not going to spend a lot of time on deploying all monitoring components. You can watch the previous video for that. First, we need to create Prometheus operator custom resources. Then deploy Prometheus operator itself, Prometheus, and Grafana. You can use either create or server-side to apply custom resources. Then create a monitoring namespace. Deploy Prometheus operator, Prometheus, and finally Grafana. In the monitoring namespace, you should have 2 pods and a single pod for Grafana. To monitor Istio, we need to create pod monitor and use Istio Sidecar labels. For example, let's get one of the pods that we want to monitor. First of all, to create a pod monitor Prometheus object, we need a named port, in this case HTTP envoy prom. In the second part, we need to select those pods based on the labels, such as Istio monitoring. Based on these 2 pieces, we can start monitoring the Istio service mesh. You need to specify the namespace where your applications are deployed, staging and production as an example. Then use selector and the port name. On line 8, Prometheus main label must match the one on the Prometheus resource. Let's go ahead and apply it. Since I don't have Ingress for Prometheus, I'll use port forward to access Prometheus UI. In a few seconds, maybe up to a minute, you'll see that Prometheus operator converted pod monitor object to the native Prometheus config and reloaded the server. Under targets, you should have a new target with a few pods. The next step is optional. I just want to show you how to use a service monitor instead of pod monitor. For example, to monitor the Ingress gateway, let's get the pod in YAML format. For example, you have a port, but the name is missing and you cannot add it for some reason. In this case, you cannot use pod monitor since you need a named port. Instead, you can create a service and a service monitor to target this port. Let's define a new Kubernetes service that only uses Prometheus port and give it a name Metrics. Now we can create a service monitor and use that endpoint and Metrics port name. It's a useful workaround when you don't have a port name and not able to add it, but still want to monitor the application with Prometheus. Let's apply both service and service monitor. If you refresh Prometheus UI, you should get a new target with gateway. There are a lot of metrics exposed by the Istio sidecars, but we'll focus on requests metrics. Since we used pod monitor for internal metrics and service monitor for the gateway, you can use a job label to filter them out. I'll use port forward as well to access Grafana dashboard. If you use my code to deploy Grafana, the username is admin and the password is DevOps123. I prepared a dashboard to monitor Ingress and mesh inside Kubernetes. You can copy JSON and import it to Grafana. Now let's simulate some traffic. On the top graph, you can find latency measured in percentiles. The second one is traffic in requests per second, and the bottom one is ratio between successful and failed requests. Let's generate some failed requests by sending requests to the not supported path. In the graph, you can see that availability drops below 80%. For the second test, to monitor the service mesh inside the Kubernetes, SSH to the pod and run another script. In the next section, we'll deploy Kiali to visualize the service topology inside Kubernetes. You can also deploy it using Helm or YAML files. You just need to watch out for external services, especially you need to provide a valid Prometheus URL. Topology graph is built based on Prometheus metrics. Let's apply it and verify that Kiali is up. You may see some errors that you need to fix by updating the config, but the main functionality is based on Prometheus. It still should work. Since some of the requests are sent to the wrong URL, you can see red lines that represent failed requests. In a large microservice deployment, it is useful to find out what service is failing quickly. If we stop our script in a couple of minutes, you should see that the service is recovered. We have the gateway, internal service, and different versions of our application. You can use UI to monitor traffic distribution when you perform Canary deployments. Istio has become de facto service mesh for modern microservices. With its advanced networking, security, and observability features, Istio provides a unified platform to connect, manage, and secure your microservices. If you're building cloud-native applications, Istio is a must-have tool in your toolkit. If you want to use Istio in production in the next couple of months, you should use Istio custom resources such as destination rules, virtual services, and others. Istio has also beta support for Gateway API to use it as Ingress, but keep it in mind that it won't work with virtual service. Also, Istio has experimental support for Gateway API in a service mesh. I have 2 other tutorials on how to implement both. Thank you for watching, and I'll see you in the next video.